So everybody, I'm very happy to be here with Dr. Aida Nematzadeh. She's a staff research scientist at DeepMind. Before joining DeepMind, she was a postdoctoral researcher at UC Berkeley, advised by Tom Griffiths and affiliated with the Computational Cognitive Science Lab and BEAR. Aida received a PhD and a Master's of Science in Computer Science from the University of Toronto, where she was advised by Suzanne Stevenson and Afsaneh Fazli, and was a member of the Computational Linguistics group. Broadly, her research interests are in the intersection of computational linguistics, cognitive science, and machine learning. Aida's recent work has focused on multimodal learning and evaluation and analysis of neural representations. During her PhD, she studied how children learn, represent, and search for semantic information through computational modeling. So it is a pleasure to have you here, Aida. Thank you so much for joining us.
Thank you for having me, and thanks for everybody who joined to the webinar.
So, we will be discussing 3 of your papers today. The links will be put in the chat for anybody who is curious. And first of all, in the paper that you co-authored titled Rethinking Evaluation Practices in Visual Question Answering, a case study on out-of-distribution generalization, you and your co-authors found that vision and language models trained for visual question answering don't generalize well. Can you expand on what a better approach would be than testing these models on data that comes from the same distribution as the training data?
Sure, yeah. So I guess maybe the first thing I can say is about the not your question, but about like the way you phrased or summarized the paper. One thing that is worth pointing out is that like when we were looking at this family of models, the idea was to look at models that are pre-trained on tasks that are not visual question answering. So we wanted to see like whether this family of pre-trained models that do typically perform very well in a range of tasks do well on out of distribution settings. So before fine-tuning these models for visual question answering, they are trained using different losses, including one that tries to match image and text modality. And then I guess to go back to your question, so there are a few things that I think we can do better. One is the idea that we basically implemented in this paper. Here we are doing what we call a transfer setting, or like an out of distribution generalization test. So we fine tune models on one particular VQA benchmark, but we test the model on test the splits of other VQA benchmarks. And visual question answering is particularly nice because we have a range of different benchmarks with different properties. So we can study how pre-training on one specific benchmarks changes the performance across a range of other benchmarks. Another, I think, interesting way to evaluate pre-trained models is just the zero-shot setting. So if we can set them in a zero-shot way, that's to directly test the quality of representations. We are not really adding any other compound from the fine-tuning experiment. And other than these two settings, I think being able to have a bit more control on the type of things that we are interested to test is usually nice. So like when we test for visual question answering, or let's say when we test for common sense, we get these benchmarks that are collected with this aim. So when researchers collect benchmarks, they have a goal and they think that the benchmarks will test for certain properties. It's not clear when we test the models, they were actually, their performance is because of.
Sorry, I didn't understand.
That was my Google Home Assistant. I don't know if you heard it, but sorry, going back to this. So like when we take a benchmark that is, let's say, designed to test for a certain property, it's possible that the model do well on the benchmark without really having the capacity or learning a specific thing that we are interested to test for, because the models can't pick up on the spurious correlations. And I think to address these probing data sets, or like data sets where we have a bit more control, are a nice way to evaluate models for specific properties.
Very interesting. And
you are muted for me.
Oh, can you hear me now?
Yes.
Great. So you did touch on this a bit. Is there anything else that you'd say on how we should test these models instead?
Oh, yeah, I guess I already answered this. I guess another way that I like to think about evaluation is being very clear about like the purpose of the evaluation. So again, sometimes we are interested, let's say, in visual question answering because we think visual question answering is a good proxy for real world application. If you have a good visual question answering system, visually impaired users or blind users can basically benefit from this system. But then the question that we typically don't necessarily answer in our works in research papers is whether this benchmark that we designed or collected data for with the hope to see better performance in a real world application actually correlates with a real world application. So if we improve on this specific benchmark, take our system, deploy it in the real world, then does this system do very well for real world application that we were interested in? I think this is a really interesting question to think about, and it's not really easy to test because most of the times researchers collect benchmarks and it's hard to actually test systems in a real world setting. So I've been thinking about this a bit more in the last few years. With the visual question answering setting, one particular data set that I found very interesting is a data set called VisVis. It's a benchmark that is collected from visually impaired users. And the setting in that work is basically the authors have a setup where visually impaired users can post a question and an image that they take. And then there's a crowdsourcing system, so like other people can answer this question given the image. And if you look at the properties of this data set and compare it with other visual question answering data set, it's very different. Sometimes the images are not pointing to the right object, or like it's just like a blurry image. Again, because of like the types of the way the users are able to take pictures. And I think here we can basically think about what is the next thing that we can do. For example, maybe the big challenge here is actually giving enough good feedback given the image and the question so we can get a better image. There's also an interesting, I guess, related to your work, privacy concern. Like there are like interesting privacy concerns given this data set because a lot of the times visually impaired users are interested in answers for questions that can be can contain sensitive information. So maybe they want to know what their credit card number is, and they're going to post an image of a credit card, or maybe they want somebody to read a document that has sensitive information. So like working with this data is particularly interesting for those reasons too.
Very interesting. And do you find, given these different testing environments that you propose, that some models generalize better than others?
In the visual question answering work that we did, we were comparing in particular discriminative versus generative models. And I mean, there's previous work that shows that generative models might generalize better to out of distribution settings because they don't overfit as much as discriminative models. So discriminative models tend to overfit a bit more. And that was basically the hypothesis we wanted to test in this particular setup. In our experiments, we interestingly see that generative models do better. They're more robust in out-of-distribution generalization in most conditions. So for a particular family of models that we looked at, the results was very strong. For another model, it was less strong, but we still see some pattern. So I think maybe like one thing to actually study a bit more in future is this difference. And maybe focusing on the generative models would be a better way to move forward.
And in one of your papers, you discuss common sense knowledge. First, I'd like to get to how you would define common sense knowledge.
Yeah, that's a very good question. It's a hard one too. I feel like we spend a lot of time thinking about this. My very simple way of defining common sense knowledge is a knowledge that is shared by typically a large group of people. It's often not mentioned, so it's often left unsaid. It's not explicitly said, even in daily communication or even like in our text corpora. And it's typically about everyday situations, like things that people kind of know about everyday situations. An interesting part of it for me is also that it's typically probabilistic. So like we might have some knowledge that, but there's usually a probability distribution over what we believe. So let's say, if I ask you how you boil water, the most common way is basically, you pour water in a kettle, you put the kettle on your stove. But this is true if you're in a kitchen. If you're in a lab environment, you're going to boil water in a different setting. So there's like some probability on like this knowledge, and it's different from facts. That like most of like it's basically true or false. It's probabilistic.
Mhm. Got it. And do you find that a model's ability to generalize is tied to a model's ability to learn what we think of as common sense knowledge?
Yeah, I'm not sure. I'm actually even not sure how to test for this. I think, like if you just think about common sense reasoning or understanding, we can test for generalization in that domain. My intuition is that it's going to be a harder generalization task because the way the models can use common sense is either by having a common sense knowledge base and basically retrieving from that, or trying to extract common sense knowledge or learn common sense knowledge from the existing corpora that we have. And if you think about this, basically what you're asking in terms of generalization to me is whether models are able to learn to synthesize common sense knowledge, which can be, I think, is a challenging task. And I don't actually know like if it's directly tied to generalization. So it's hard to test for it in a way. So like you want your model to do well in, let's say, in a generalization setting. Is the test for generalization the ability to synthesize new knowledge? How would you test for it? You kind of need to have manual annotations of what the knowledge is produced, and go from there. It's an interesting question.
I guess one way to start might be to compare which models do better in common sense knowledge tasks, and which models generalize well, and see whether they are similar.
So by generalizing, I guess when you measure generalization, it's typically per task, right? So when you say models that generalize well, is it for like the question is for what task we're going to test for? In the current like most recent line of work, the base models are typically a language model, and we pick a language model that generalizes well in a sense that it's doing well on the validation or test set. Sometimes if we have that, actually with the larger language models, this is also really hard to measure. So it's not out of distribution generalization necessarily, it's just a better model. And given the current common sense benchmarks, I think we will probably see a correlation between performance in language modeling and performance in common sense benchmarks for most of the existing benchmarks. But I don't think that is necessarily a generalization in the domain of common sense. Does that make sense?
That makes sense. Absolutely.
Yeah.
So this paper that you authored called "Do Language Models Learn Common Sense Knowledge?" I was curious about what some best practices are to test for common sense knowledge.
Yeah, I think when we started working on that project, the dominant approach was basically taking some existing models that are either pre-trained for language modeling in the like encoder style or like autoregressive language modeling, and then fine-tune for common sense benchmark. And then when we started looking at this line of work, the main, like I think the interesting question for us was whether if we take a very good language model, like this larger family of models, are they actually able to learn what we consider common sense given our existing benchmarks by just the language modeling objective, basically. So for that question, I think the zero-shot evaluation was an interesting one because we are not really going to teach the model about common sense at all. We're just going to see whether the model is able to learn. Having said that, I mean, if the goal is to come up with a system that is really good at common sense reasoning for a specific application, I think fine-tuning definitely makes sense. So I think I would answer this question by adding maybe a phrase to it, which is like, what do you want to do with this system that we're evaluating? And identifying that would help us think about what are the best practices for evaluation or for test. If the idea is to test a model for their ability to learn common sense knowledge in, let's say, in a semi-supervised or unsupervised way, then I would test it without fine-tuning. If we were interested in having systems that work very well in a specific benchmark, fine-tuning is fine. Something that's also interesting is that people typically like some of these common sense benchmarks are created from a knowledge base that are based on a knowledge base. So it's possible that you actually use that knowledge base as a signal during training. And I think thinking about like how general these knowledge bases are, and like how well the models that use each types of knowledge work or basically perform for different common sense benchmarks is another interesting question.
Definitely. So moving to this other paper that you co-authored called Probing Image Language Transformers for Verb Understanding. You mentioned that certain categories of verbs are particularly challenging for image language transformers to learn. Can you tell us about these categories and about what kind of data sets would help with training models to better deal with these verbs?
Yeah, so in that paper, we couldn't really identify a particular category based on the properties that we looked at. So one intuition that we have was that some of the verbs are known to be more visual, meaning that like it's easier to see them in an image. And we had a data set from a previous work called Image Situations, where the authors of that paper have basically asked annotators to identify whether a verb is visual or not by basically checking whether they can find images for that verb. So that was like one a specific thing or like a hypothesis that we could form and test for. Interestingly, we didn't see a strong correlation between performance on the verbs across this family of models and whether the verbs were visual or not. We also tried to look at for a few other properties of the verbs, but none of the results were really, I would say, very like there was no strong correlation. One thing that we didn't look into in that paper, and I think might be important, this was something that I thought afterwards, and I haven't actually tested this empirically, is I think one interesting part of the difficulty of the verbs might come from the types of images they occur in and how visually different these images are. So if you think about like a very simple verb of eat, it can happen in very diverse environments, like animals eat in, you know, I don't like in an environment that's very different from how people typically eat, which is like in a kitchen or like in a restaurant or like, you know, in the street. So that might be actually one thing to check for, and I think it would be interesting to test for that. And I guess the second part of your question is what kind of data sets would help with training models to better deal with these verbs? That's an interesting question. I think there's like a question whether like we need different data sets or maybe we actually need different ways of modeling for verbs. And I guess like I would say we probably just need better models, and maybe we can learn from existing data sets. And the reason I think that is that like typically when we consider learning in the grounded setting with images and language, we have like there's a lot of work that focuses on objects, right? And objects are interesting, but they're very easy because we can model them as a classification task, so we can predict the object alone. Verbs are a bit more interesting because they're about relations. So if you want to model verbs, we need to actually learn to predict a relation. So it's a structured prediction task, or like predicting the relation. And none of the existing models, like the recent family of models that we were testing, these larger pre-trained models are not really specifically trained to learn relations. And I think that's basically maybe, that's an interesting future work. That's what might help these models to do better for verbs.
Great. And tying that in, to what extent do you think that verb comprehension can be a test of common sense knowledge?
Yeah, that's an interesting question. I guess maybe one thing to consider is actually whether verb understanding is common sense. I probably would have, if you had asked me, what type of common sense knowledge is there, I wouldn't call like linguistic knowledge as common sense. and I don't know if I have a very good reason for that, but like there are like different types of knowledge that we have, and I think knowledge about language is something that we learn, but I wouldn't consider it as common sense, although like it has a lot of properties that I probably I listed when I define common sense knowledge. Maybe yeah, I don't know why. I mean, like partly it's that it can be probabilistic. It is it's something that we use every day. It is shared by a large group of people. But it's also something that we kind of like learn specifically, and then we take it as a knowledge that we have. I don't think I have a good answer for this, to be honest. Yeah, I have to think about it more.
I could see why that would be a difficult thing to debate.
Yeah, I think like basically there's this question like what is knowledge and what is common sense knowledge, and like knowledge about different fields that we learn, like chemistry, language, even physics. There's like a lot of common sense data sets across that is about physical or temporal knowledge. But maybe the way that we can think about it is that like when it's common sense knowledge, it's more about like combining that information with our everyday situations, as opposed to like learning a specific sets of like facts or even like knowledge about a specific domain. Yeah.
Maybe temporally speaking, one piece of common sense would be if you are boiling water, you probably put the water in the kettle before you boil the water, and that a verb would be able to tell you when that water was put in the kettle.
A verb would be able to tell us as like when you're boiling, you know that the water is already in the kettle. Yeah, that's actually a good example. So it's a common sense knowledge that we know by learning, I guess, about the verb meaning. But maybe it's like something that you actually synthesize from that verb meaning, and you use it.
Yeah, I can see that. So we have 6 minutes left. I have a few more questions to get through with you.
Okay.
How well do you think tests for common sense knowledge in purely language transformers transfer over to image language transformers?
So when you say the test for common sense knowledge, are you asking whether the benchmarks that are language only are good benchmarks? I think that's a very interesting work, like direction for future work too. So we did some experiments where the idea was that like we have all these benchmarks that are language only in a way that people have been testing them on language only corpora. If we use images, if we ground them on a different modality, can we do better? Like assuming that some of the things that are not said in the text might be visual in the image. So given the current benchmarks, I think maybe for some of them there is some information that we can find from images, but it's really hard because a lot of these data sets again are curated based on some specific knowledge bases that are text only, and then finding images that depict information for those it's not necessarily easy, particularly some of the benchmarks that we looked at, like for example tests for social common sense or even the ones that test for temporal common sense are not really it's hard to find like retrieve useful image data sets or basically useful images for them. But then my intuition was that for some of them, like maybe for the ones that test for physical common sense, we can find some useful images.
Makes sense. So thank you for all of that discussion on your papers or your more recent work. Moving towards what you're currently doing at DeepMind, is there any research either from yourself or somebody else's that you're most excited about at the moment?
So recently I've been reading a lot of papers and modeling structure. In particular, I've been reading a lot of papers from Yoon Kim. So I'm excited about that line of work and thinking about like how we can model structure in the multimodal setting. Other than that, I'm also, this line of work that I already mentioned, I'm also very interested in captioning for blind users. I think it introduces a lot of interesting problems that we typically, or I haven't been thinking about when we consider other benchmarks. One interesting, for example, challenge with this data set that they actually need to do pragmatic reasoning. Like a lot of times, the language use is a pragmatic use, and I think that's a very interesting problem to study.
Mm-hmm. Very interesting indeed. And just out of curiosity, what is it like working at DeepMind?
Yeah, that's a great question. Working at DeepMind is fun. So, like, I guess if I want to just give a very short answer to this question, to me, it's really it's similar to working in an academic setting, like as an academic researcher. Maybe with a different distribution of tasks. So like we probably have very similar tasks, but depending on where in academia you are, you might spend different amounts of time on the tasks compared to like me, for example, at DeepMind. We have a lot of focus on research, for example. I still find opportunities to teach. I enjoy teaching, but it's not mandatory or like a big component of our job. We are lucky that we don't also have to apply for grants to do our own research, which is very helpful. So we can basically just focus a bit more on the research part.
Love it. And is there anything you'd recommend to researchers looking at applying to DeepMind?
Yeah, good question. So I think maybe like one question that I get a lot when I talk to people is what sort of research is going on at DeepMind. And I think like now we are a bigger company, it can be, and we try to have like a lot of information, like public facing information for people who are interested, but I feel like sometimes people are just like curious, like, what are the opportunities, or like what type of research they can do at DeepMind. And I think for that, maybe like my recommendation is that if you're at a conference and you see a DeepMinder or there's like a recruiting team at the conference, talk to people. I think that's the best way maybe to kind of get a sense of like the different types of research that people do and the different groups at DeepMind, and figure out if there is a match for your interest at the company.
Great. So we are almost out of time. Do you have maybe 2 more minutes to answer questions?
Sure, yeah.
Great. Does anybody in the audience want to ask Aida any questions? What are the exciting use cases for structured data modeling? For example, do you apply them to biology and chemistry problems?
For me, I'm like the reason I'm excited about it is mostly like the image language benchmark that I've been looking at. So if you think about something, even like visual question answering, a lot of times their structure and the language is important for the model to answer the question correctly. So that's why I'm interested in it, basically.
Any other questions? All right. Aida, thank you so much for your time. Such a pleasure to speak with you.
No worries. Thanks for having me. Have a good day.
You too. Have a great day, everyone.